There's no need to get tenser. Relax with Flux Condenser. Subscribe, baby, subscribe.
Since 2005, this Lexicon MC-12 processor has been the heart of my home theater. A few weeks ago, though, it refused to start up. I went to the back of the unit and immediately cut power, as I could hear a crackle from about where the power supply would be. Given that it's 15 years old, I looked into replacing it with something new. Very quickly, though, I realized that doing so was not only going to be very expensive, but also a pain in the neck. Not only would I be paying for essentially the same features I've always had, and many that I didn't need, I'd have to reset up my system from scratch. Plus, I'd invested in pricey balanced cables, which most new processors don't work with. Most importantly, though, I was afraid I'd miss the MC-12's stellar feature, Logic 7. Logic 7 is Lexicon's proprietary algorithm for creating extra surround channels from stereo or 5.1 audio, whether analog or digital. I love how it sounds with stereo signals from CD, tapes, or records. There are other systems, but Lexicon's was, and probably still is, the best. So I put the MC-12 on my bench, opened it up, and here's what happened. Okay, finally got the MC-12 opened and got this board out, which contains the power supply. And as suspected, I believe the problem is with the power supply. When this was first going bad and I had this in the component rack, I could hear sort of a sizzling sound coming out of this corner from the back. So yeah, I got it opened and pulled it out, disconnected it, and yeah, some of the caps have some ooze coming out of it. This one here, I'm not sure if you can see that. My plan was that I would rebuild the power supply by replacing the capacitors, all the electrolytics. But on closer inspection, I noticed on the back, looking at a number of these SMD components, yeah, it looks like there was some type of I don't know if it was a fire, probably not, but something, this area here is clearly overheated, and these SMD components look distressed, and looks like they may not be 100%. So I didn't want to get into replacing all these SMD components and diagnosing this maybe for somebody else, but not for me. It's just not worth it. Because I was able to go online and get a replacement. And I'll show you here from Sega Electronics. Hopefully you can see that okay. The model number on the power supply, it's an EOS, and the model number is VLT 110-4302. And sure enough, on Sega, I was able to find the exact replacement for a 102.84. Now, I also discovered that they have a medical version of this power supply available for a little bit more, 106.54. The model number is the same, except now after the, let's see, this one is LFV, the original, and the medical version is LFM VLT, and all the other numbers and letters are the same. Medical versions of power supplies are supposedly more durable, more able to handle higher stresses, things like that, because they're being used for, in hospitals and things like that, where reliability is a must. I'm not sure if the components are exactly are different, or if they're exactly the same or not. Sometimes by designating something as medical or for professional use, all it really affects is the warranty. You get additional coverage. I wasn't sure, but for a, let's see, 102 to 106 for a $4 difference, I figured, what the heck, I'll get the medical version. Okay, and I ordered that from Sager.com, and it arrived within a week. They're located in Massachusetts, as am I believe. So, well, I know I'm from Massachusetts, but I believe they're from Massachusetts as well. So that certainly sped up delivery. This is the replacement. Okay, let's take a close look at it. It comes in an anti-static package. And, oh, yes, actually, looking at it, does appear that the electrolytics are different. If you can see that, these have a kind of a pink band on them, whereas these look more typical. Yeah, these don't look like ordinary electrolytics to me. Those do look look like a higher grade capacitor. I can't be sure, but given this is the medical version, that's probably the case. And let's see, everything else. Yeah, even this this might be the safety cap. Looks different here. This one here, the blue on this board, and it's gray on this one. It's actually stamped with an M. That could stand for medical. All right. And the pin inputs look the same. That's good. So we'll be able to connect this right to the Lexicon. Pins here as well. Let's look on the other side. So maybe here you can really see the difference in the colors. You can see how brownish and yellow this got from overheating. And these components look very similar. The new components look very similar to the old, but definitely a difference in the electrolytics. Okay. Set that aside. Okay, so I'm going to go ahead now and install the new power supply into the chassis, and hopefully that'll take care of all the issues. If not, we'll go from there. But if there are additional issues, I really can't diagnose them until we have power into this thing. So let's give it a shot. Here we go. So let's get the board in place. Screw it down before we attach the connectors. You notice that on this board, it's not part of the power supply, but part of Lexicon's board. There is a fan here to provide cooling for this. We'll try to see. This was probably only going to go on when the cabinet heats up significantly. But I want to keep an eye on this and see if this is turning on, because possibly it could be that the fan is not working, and that's contributed to the power supply overheating. We'll see. All right, now that that's buttoned down, let's go ahead and reattach our connectors. And the fan connector. Go back and check. Did that connect here originally? Okay. There's a 2-pin connector here. I've got to go back and check my photographs, but I think when I took this out, this was disconnected, the fan, so I'm not sure if this goes to the power supply or here, as you'll see down on this this main, looks like the main board underneath this. Let me point to it with a pencil. And you see that this main board underneath covers the entire area of this chassis. And right here, there is also a 2-pin connector. Let me line it up and see quickly, and see if one, just as far as the length of this, it seems more likely that it went one way or the other. Does look as though this wire wants to go this way and not this way. So that might be a clue that it does not attach here. Does not attach here, but attaches to the other board. Drop that in, and I can consult my the photos that I took too and see if I got a shot of that. Alright, not sure. Let me look at the photos and see if I got a shot of that. Okay, yeah, we see that the fan is not connected here. There's the fan wire here, going from the fan, and definitely looks like it's going down to here. Now, note that when this photo was taken, all the other connectors are still attached. However, the one for the fan is not. This was intended to go here. Perhaps this was never installed. Or it became dislodged over the years, and maybe, just maybe, without the fan running, if that's the case, if this has become disconnected, that contributed to the power supply overheating. All right, let's get this in place. This was very difficult to remove because of the way that they had, I may have to change the angle of the camera to show you the way that the this metal bracket kind of slipped in between these two parts. I took it apart a week or two ago, so I don't recall, but I know it. I had some trickiness with I think this part here, because it slid in between these two pieces of metal. So let's see if I can see if I can get this in. It was so difficult to get out that I actually may consider making a modification to this. I might actually elect to snip some of this metal off if I deem that it's going to help get this in and out more easily. Just trying to be careful I don't pinch these wires. This wire here in particular. Trying to see if I can get this board in by just pushing this flush up as far as I can, but it doesn't look like it. Again, I think this bracket needs to slip in between those two. I might pick this up and take a look at the back side. All right, well, it actually does look as though I could, this will fit in here, and the screw holes align, even if I don't slip this board underneath between these two pieces of metal from the back panel and the side panel. If I can do that, that's the best way. It'll make this a lot easier to take in and out. Okay, so let me just double check that. Put some screws in there and see. Okay, so to put the MC-12 back together again, as you can see, I have a number of screws, all different types. To make it easy on myself, I'm going to consult the photos that I took when I was taking it apart to help me recall my memory a little bit to figure out which screws go where. So I'm just flipping through now. There's one photo showing this panel already removed. Let's go back a little bit. Well, in the back, using these rounded screws, and those would go in the back here. Get that one started. So the machine screws don't look like they're fitting. There's a couple of these wood type or sheet metal screws. Let's give that a try. All right, that seemed to be a good fit for there. And I have one other sheet metal type screw. Let's try that here. Okay, so now we have the board attached to the rear panel. We also have two screws here and a couple on the bottom. And let's see. Those appear to be the the small black machine screws that were used on the bottom, so perhaps those were used on the side as well. Let's see if I can get those in there. Okay, got one side screw in. Let's get another one. Okay. Before we fully reassemble this, let's just test it out and see. Let's plug this cable in. Tuck the cable down underneath. Pull it out from the other side. Okay, got it. All right, there's the cable for the fan, and that is going to connect right in there, if you can see that, okay? It's gonna go this way. Okay, so I just used the needle nose to attach that. You probably can't see too well on the camera. That is in there now. The fan is connected to our main board. And let's just double check all our other connections. Okay, looks good. And from the back, our switch and our plug for the power, okay? Still a little loose because I haven't attached the screws in the bottom. Now you may notice that there's this pigtail now coming out the back. That connects the balance module for this. I believe the MC-12 was available in a MC-12 and an MC-12B version. This is the B version. It was a bit cost a bit more because it offered the use of these balanced jacks for balanced cables. So I happen to use balanced cables in the system. Very sort of professional oriented cabling, and balanced cables are great to prevent hum if you're very long lengths of cable, or and again in a professional setting they're sort of a must, because again you're using so many cables and at great lengths, so the balance really helps to make sure that the extraneous noise that gets picked up on the cable is eliminated. It's questionable whether you would need that in a high fidelity system. Back when I purchased this, I was I was a sort of a more of a proponent of exotic cables and things like that, so it kind of was in line with my thinking at the time. The reason why I bring it up now is if I power up the MC-12, it may go through a self-test, where it's going to look for this board, and if this board's not there, we might get a fault. So I'm going to see if I can possibly, may just temporarily connect this to this and lay it underneath, and let's just test it with the board connected so we don't have any issues there. So let me see if I can figure out a way to do that quickly without putting this entire thing back together again, because I really want to test the power supply first, let it run for a bit, see if the fan kicks on before we put this together permanently. Okay. All right, so the balanced input board connects with this ribbon cable here through that jack, and it's actually the balance module is part of the base of the MC-12. It's built into there, so we should be able to now just rest this on top, get it aligned more or less where it's going to go. Did I do that right? Yeah, something like that. Okay. Alright, just double check our work. Everything seems to be connected and in order. Let's get let me get a power cable for this. Let's plug it in and give it a try. Okay, since we're starting this up for the first time with a new power supply, let's start it up slowly with the variac and also use the current limiter, and for that we're using a dim bulb. So also I'm going to monitor the AC voltage on this old Heathkit meter, so that will plug directly into the auto transformer. This is also an isolation transformer as well, and the dim bulb will also plug into the variac auto transformer. And we're going to now plug in the MC-12. Okay. This uses a 3-conductor grounded cable. Now that will plug directly into the dim bulb. Okay. So you see that? This is not like starting up an antique radio, since this is a computerized processor. It may not like a low voltage situation, so I may need to ramp it up quickly so that it will actually activate. And also this has a standby switch with the relay, and again that might actually look for a certain voltage. So let's give it a try and see where that point will be. The current limiter I built with an on-off switch. Let's put that in the on position. The variac is now in the off position, and at 0 let's turn it on and start it up. Let's also make sure that our rear switch is in the on position. It is. Okay. And there's also a front panel switch which turns the MC-12 from on and off from standby mode to active mode. So I'm just going to ramp it up and just looking for faults. Oh, and okay, we're getting a flash. Okay, I don't think starting this up with low voltage is a good idea. Let's turn this off. I will start it up with the dim bulb, but not the variac. It seems to be creating some issues here on the board. I see lights flashing on and off. Again, this may not like low voltage. Let's get this out of the circuit. Let's start it up with full voltage, however, with limited current. Okay. This is a 100-watt bulb. It's likely to burn fairly brightly with this, but let's give it a shot. Go to on. Okay. And flip that to on. Turn that off. Again, it's a switching power supply. It seems to be triggering this on and off with the current draw. I think we're just going to have to plug this in directly and forego the current limiter and the variac. Everything is going into this new power supply, so shouldn't be any issues. All right, let me just flip this to the off position. Full power. Okay, we've got some LED lights turning on here on this board. Okay, we're starting up on the front screen. The Lexicon logo is turning on. It's doing the diagnostic tests. Still going through the diagnostic tests. And looks like that solved our problem. I've got a screen here that says Lexicon MC-12, version 5.0, copyright 2005. Okay. Yeah, I think that did the trick. Let's let it run for a bit. Maybe I'll see if I can just put the cover on or something to sort of simulate. Of course, it's not going to be working, so it may not be under a large enough load to generate heat, but I am curious to see if that fan is going to turn on or off. It's off now. This is warming up. Maybe just, again, I'm going to put a panel over this to simulate like this, to simulate the operating conditions with the cover on top. And let's see if we can get this to heat up a bit and get that fan to turn on. So I'll monitor that. Okay, so we've had the processor running on the bench for many hours now. Everything appears to be fine. The only issue is potentially the fan, the cooling fan, which I had mentioned here. I have not been able to get the machine to activate that fan. It's probably not a problem because this power supply is medical grade, and it's fairly well ventilated in here. The top cover here that goes over this area here is vented. Nonetheless, I just wanted to make sure that the fan itself is working. So what I've done is I've hooked it up to a power supply here, and looking at the fan, it's a 12-volt fan. So let's see, just to make sure that the fan is working. So here we go. It's all wired up now to the power supply. Let's turn it on. Okay. And let's give it a little volts and see if we can, what you're looking at here is the fan right there. Let's see if, there it goes. Yep. Right about, turns on right about 5.1 volts, 5 volts or so is when it turns on. It's designed to operate at 12 volts. Let's get it up to 12. There we go. And we can hear, I don't know if you can pick it up, but there's a quiet whisper of the fan. So the fan itself is working. However, for whatever reason, the machine isn't activating it, whether that's a fault due to the processor, or if it's just that it really takes a very, very hot condition for it to activate. I'm really not sure. Again, not too worried about it. I did test, I don't know if you can see it back here, but I showed you on the power supply. There is a 2 pin outs here, which actually were the same size as the socket and jack for the fan. And checking the voltage on this, I think it was about 3 or 5 volts, but I don't think it was designed to be used for a fan actually, because looking at the literature for the power supply, I think that's just used for to show a test condition. It gives a voltage if everything's operating fine, and no voltage if it's not. So I guess that can be used just to have an indicator light or hooked up to a computer, which will tell you whether or not the power supply is working. So I think that's all that's for. And it doesn't operate at a high enough voltage, really. Again, not quite high enough to drive the fan. So the fan is working. I'll hook it up back to the processor. I'm going to try one more time to leave it on with the cover, get it to heat up a little bit, and see if the fan activates. But I will say that even letting this operate with the cover on, it really doesn't get that warm in there. This is not an amplifier; it's more of a preamplifier processor, and there's some chips in there that get hot, but it's not like an amplifier where you have big transistors running and power supply caps and things like that. And this is a switching power supply which operates relatively coolly anyway. So okay, let me do some more tests and I'll check in with you. Okay, what you're looking at here is the image of the MC-12 through my FLIR thermal imaging camera accessory that I've attached to my iPhone. And the reason I've done this is because I have not been able to get the fan to turn on in this chassis. So this is just an attempt to see what kind of temperatures are really going on inside this chassis. And the FLIR will allow us to see that, and it will give us an indication of what the temperatures are. So what I've done is I've operated the MC-12 now for many, many hours. And it's processing a 2-channel analog signal, and converting that to a 7-channel surround sound signal. So it's been busy at work doing that, and it's currently doing that as well. So just a chance to get the processes to heat up a little bit. Right now, the lid, okay, this area here with this darkish red, okay, you can see my finger pointing here, and here's a pencil, okay, is, according to the FLIR, that's at about 105 degrees Fahrenheit. Let me just touch that. Yeah, not too hot, just about 100 degrees. What I'm going to do now is I'm going to take the lid off, and I'm going to look at the scale. You can't see the temperature scale. I don't think that gets recorded when I do a video with the FLIR, but I can see the numbers here. Again, right now it's saying 100.5 degrees. When I take the lid off, I want to see what the hottest temperature is inside the chassis, okay? Because I do know, looking at the literature for the power supply, that the operating temperature is supposed to only go up to 158 degrees Fahrenheit, okay? Now imagine that's the ambient temperature where it's allowed to operate. The different parts of the power supply could, of course, get hotter than that. It's more of the ambient temperature we're looking at. So if I take the cover off and I see that the hottest thing is 158 degrees, then we're going to be just fine, because again, that's just the spot reading, and we'll try to look at some of the cooler areas to find out what the actual ambient temperature is, okay? So I'm going to do that now. Okay, I'm going to reach down. I'm taking the cover off, and I should note that this has been operating with this cover on, and if you can see these rectangles here, okay, that's some tape that I've placed over the vent holes, okay? I have covered all of the vent holes for the MC-12, okay? All ventilation has been covered by duct tape. That goes for tape along the sides as well, which you can't see here, okay? So again, this is kind of a worst case. Just how hot can this get operating it for several hours while processing and actually functioning, okay? So just to see if that fan doesn't go on, if it's still operating under safe conditions, okay, for the power supply. Here we go. Okay, now the yellow areas I am seeing are, yep, right about 157 degrees. And so you can see over here, where the capacitors are for the power supply getting quite hot. This area here, this is the analog board, okay, in here. And because it is processing an analog signal, you can see that the analog board of the MC-12 is very, very busy right now and getting hot. But again, only about 100, and now that I've taken the vent off, it's gone down to about 155 degrees. So I don't see any real concerns here. Again, the operating temperature for the power supply is supposed to be a maximum of 158. Only the hot spots here are getting up to that temperature. The actual ambient temperature within here with the purples, etc., are going to be really just a little bit about 100 degrees, a little bit more, 120, 130. So should be just fine. And hopefully if things did get hotter, the MC-12 would finally turn that fan on, and hopefully there's not a fault here. But as I can see it, I don't think we're going to have any problems with the power supply overheating because of some type of problem with the fan not working. This situation seems to be just fine, and the power supply should be able to handle it. So why don't we go ahead and put everything back together again, get this MC-12 back in service.